Namaste Gate aspirants, welcome to the GateTuber YouTube channel. Today, let us do some problems on kinematics of particles in plane motion. So here is the first problem. A stone falls past a window of 2.45 meters height in half a second. Find the height from which the stone fell. What does it mean? There is a building and there is a window in it somewhere in the middle or in the end or in the top of the building. We are throwing a stone by free fall from somewhere of the building above the window. The window's dimensions are 2.45 meters height, and we need to find the height from which the stone fell. Here, as the body is in free fall, we need to understand that it is under constant acceleration. That acceleration is obtained due to gravity. So we have a acceleration which is caused by gravity, that is equal to g is equal to almost 9.81 meter per second square. So now after getting this, we can use equations of motion, isn't it? The acceleration is constant, we can use equations of motion which are derived in the previous class. So just apply those. Let me write those here. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. In the place of a, everywhere in the problem we are going to use g, because the stone is falling downwards, that is towards the earth, and the gravity is also towards the earth. A is equal to plus g. If it is thrown upwards vertically, then we will take minus g. Here, as it is falling vertically downwards, we will take a is equal to plus g is equal to plus 9.81 meter per second square. So now see, if we take the distance s as h, and if we substitute a is equal to g, what we will get? There is no initial velocity for the particle, hence h is equal to half into gt square. Let me clear that with the diagram, what is h and all. So see, I have drawn a building there. See, on the building, somewhere in the middle, I am taking a window with 2.45 meters as height. So there is a crane on the top of the building that is throwing a stone. Let me assume that above the window, the height is h meters, and below the window they did not specify where the window is located. So I am going to calculate the height from which the stone fell above the window. Okay, so with that I can say that h plus 2.45, to travel that h plus 2.45 distance, I will substitute it as s. So half into g into t plus 0.5 whole square. Since they have given to travel the distance of 2.45 meters of the window, the stone takes 0.5 seconds. So we have two equations here and two unknowns. H and t are the unknowns. So let us solve the equations. How do we solve? Let me name the second one as 2, the first one as 1, and I'll subtract 1 from 2 so that I'll get. So if you remove 1 from 2, you will get 2.45 is equal to half into g into do a plus b whole square for t plus 0.5 whole square and remove t square there. So finally you should get t is equal to 0.2495 seconds. And if you substitute the t value in the h, you will get height as 0.305 meters. That is the stone which is thrown from the height of 0.305 above the window. So in this question, actually they have to specify which height they wanted to calculate us, because they wanted us to calculate the height from which the stone is thrown downwards. So, and as they did not give the location of the window, I assume it as that is almost present on the ground, and below that there is nothing. So the height from which the stone fell is h plus 2.45 meters.
Please hit the like button, subscribe to our channel, share the video and click the bell icon to get our regular updates.
Now let us see the second problem. Velocity of particle moving in a straight line is given as v is equal to 2t cube minus t square minus 2t plus 2. Now find the acceleration of the particle in 20 seconds. After 20 seconds of the travel initiation. That means after starting the travel, after 20 seconds, what will be the acceleration of the particle if the velocity profile is given as 2t cube minus t square minus 2t plus 2. As we know that acceleration is the rate of displacement of velocity. So simply derive that equation with dt and we will get 6t square minus 2t minus 2. So 6 into, in the place of t, just substitute 20 minus 0 whole square minus 2 into 20 minus 0 minus 2. So 6 into 20 square minus 40 minus 2. So 400 into 6 is 2400 minus 42. So that will be 2358 meter per second square. Okay, I hope you understood. In this problem, they also can ask to find the displacement after some time. So what we'll do there? So velocity is rate of the displacement. So we'll put ds by dt is equal to 2t cube minus t square minus 2t plus 2 and we'll integrate. Okay. Now let us see next problem. A body is projected at 30 degrees to the horizontal. Velocity of the projectile is 10 meters per second. Here the velocity of projectile is given and at which angle it is projected is also given. And what we need to find here, find the maximum height reached. Oh, this is a multiple question. So there are 3 questions I guess in this question. So first we need to find the maximum height reached, second is the range, and the third one is time of flight. What is time of flight? Time of ascent plus time of descent. If you remember all the formulas in the previous lecture and you have made a summary, If I did not make the summary in the previous class, please make the summary of the formulae which I have noted them in the boxes. Those should be remembered for easy solving of the problems. So maximum height reached is derived as v0 square sine square theta by 2g. These all equations are derived from equations of motion only. So v0 square, the initial velocity is given as 10 square and angle of projection is given as 30. So sine square 30 by 2 into g, I am taking it as roughly 10 meter per second square. So 5 into 1 by 4 is equal to 5 by 4 meters. Range. Range is given as v0 square into sine 2 theta by g. So simply substitute the values there and get the result. 10 square into sine 2 theta is what? Sine 60 is root 3 by 2. If you are unable to do like that, simply expand sine 2 theta as 2 sine theta cos theta, which I did here, and divided by 10. So finally you will get 17.3 by 2, that is 8.6 meters. Next one is time of flight. Time of flight is the time that is spent by the particle after throwing to reach the ground. That means it will reach the maximum height, which is called as time of ascent. After reaching the maximum height, it should reach the ground again, that is called as time of descent. So Ta plus Td is equal to V0 sin theta naught by g is the time for each one. So we multiply it by 2. So 10 into sin 30 is 1 by 2. So 5 by 10 is equal to 0.5 into 2. So that will be equal to 1 second. How do we get the time units here? Simply put meter per second square, second in velocity, meter per second square in the acceleration. So if you see that meter per second into second square by meter, and all thing cancel up, finally you will get seconds. I hope you understand this problem. Now let us go to the next problem, which is a previous gate question. X is equal to 2t cube plus t square plus 2t is given as the rectilinear motion of a object. So v and a are the acceleration and velocity of the particle, and the motion started with he asked that how the motion started. That means he is expecting to find velocity and acceleration at the time of beginning of the motion. So he has given some options. If you clearly observe, v is equal to 0, a is equal to 0, b is v is equal to 0, a is equal to, c is v is equal to, a is equal to 0, d is v is equal to, a is equal to. Here some guys simply will put v is equal to 0, a is equal to 0 as the initial condition. But as the equation is clearly given, we need to derive the whole thing and then decide if it is 0 or something, because every motion may not start with 0 as velocity or acceleration. Some motions may have finite values as acceleration. So let us find velocity as dx by dt, and 6t square plus 2t plus 2 is equal to 2 meter per second. That is what we got as velocity, with which the object is beginning its travel. And the second equation, for the second term, see, we have got velocity as 2. So a and b are cancelled. Why we put the t is equal to 0? Because the motion is starting. When the motion starts, from time 0 only, right? And similarly A also we got as 2 meter per second square, since A is called dV by dt. I hope you guys understand. So we got the final answer as D. Let us see next problem. A body is projected at an angle such that its range is equal to 3 times of the maximum height. That means a body is thrown with some angle, with some velocity, and it has traveled some distance vertically and horizontally, and in that motion the range obtained is equal to 3 times of the maximum height. So what we need to find now? Find the angle of projection. To find the angle of projection, what we need to do?
Completed writing the notes or not? Please hit the like button, subscribe to our channel, share the video and click the bell icon to get our regular updates.
As we know the equations of range and maximum height, we will try to simply apply the condition and put the equations in the condition. Let us see what we'll get. So as we all know, the range is obtained as v0 square sine 2 theta by g, and the maximum height is obtained as v0 square sine square theta by 2g. So as the condition is given as r is equal to 3h, let us simply substitute the derived formula in the condition. So if we substitute, we'll get v0 squares cancelled, g cancelled, and sine 2 theta expanded, 2 sine theta cos theta is equal to 3 into sine theta into sine theta. So finally, if we send cos theta that side, we'll get tan theta is equal to 2 by 3. So the angle of projection will be theta is equal to tan inverse of 2 by 3. So just calculate with a calculator and let me know in the comment section what is the angle.
Completed writing the notes or not? Please hit the like button, subscribe to our channel, share the video and click the bell icon to get our regular updates.
Let us see one more question. From the top of a tower of height 36 meters, a ball is dropped, and from the ground a ball is projected vertically. That means what? Some guy is there on the top of a tower, he is freely leaving the ball from there, and I am there on the ground and I am throwing a ball vertically upwards with some initial velocity 18 meter per second. So now what we need to find? The distance both the balls meet from the top of the tower. So the balls both should cross each other at some point of the building. So from that point we need to find what is the height of the building. Okay. So how do we do this? For these kind of problems, better if we draw some diagram for easy understanding and using values and variables. So let me draw the tower, and the height is equal to 36 meters. Initial velocity of the body which is thrown from the ground is 18 meter per second, which is freely falling. It will have acceleration which is due to gravity, that is g is equal to 9.81 meter per second square. So let us consider the balls cross at a distance y from the top of the tower, and under that there should be 36 minus y as the distance. So if we apply equations of motion, S is equal to ut plus half at square. For the ball which is thrown downwards, there is no initial velocity, hence y is equal to half into g into t square. So, and v square is equal to 2g into y. That is obtained from v square minus u square is equal to 2as. We substitute g as a as g and y as h or s, and v is equal to g2 is the another equation. And for the ball 2, let us write the equations for that also. That is 36 minus y is equal to 18t minus half gt square. Since the ball is traveling from the from the ground, so I got 4 equations and how many unknowns? 3 unknowns. So I hope I can easily solve them. So simply add up equation 3 and equation 1. So that we'll get 36 is equal to 18t, and finally we'll get t is equal to 2 seconds. If we get t is equal to 2 seconds, we'll simply substitute the time in the first equation and we'll get the half into g into 4. So 10 into 2, that is equal to 20 meters roughly. Okay, I hope you have understood all the problems and all the previous video lectures in my lecture series. If you have any doubts anywhere, please contact me, which is left in the description, or please leave a comment then and there itself. So thank you guys. This is it for today. We'll meet in the next lecture.